Good day, everyone. Our topic for today is all about factoring polynomials. So, how to factor polynomials? In factoring polynomials, we need to first understand or review about the greatest common factor. So, paano pa kumuha ng greatest common factor? Factors are either numbers or polynomials. When an integer is written as a product of integers, each of the integers in the product is a factor of the original number. When a polynomial is written as a product of polynomials, each of the polynomials in the product is a factor of the original polynomial. Factoring, it is a process of writing a polynomial as a product of polynomials. The greatest common factor, on the other hand, are the largest quantity that is a factor of all the integers or multiple polynomials involved. Finding the GCF of the list of integers or terms. First, the prime factor the numbers. Second, identify common prime factors. And then take the product of all common factors or prime factors. If there are no common prime factors, the GCF is 1. So, example, find the GCF of each list of numbers. Number 1, 12 and 18. So 12 is equal to 2 times 2 times 3. Those are the factors of 12 because 2 times 2 is 4 times 3 is 12. 8 is 2 times 2 times 2. So the common factors that we have here are both 2 and 2 and 2 and 2. Ito yung mga pareho. These are the similar factors that we have for 12 and 8. So we will get them. So we have 2, 2 for, we have the same, right? So we have 2 times 2 is equal to 4. Another way to get the GCF is by doing this symbol. So we have 12 and 8 as our numbers. So our main target here is to divide both numbers with the two numbers, okay? Make sure na kapag nag-isip ka ng number na i-divide mo kay 12, pwede rin siyang i-divide kay 8. Pag wala, 1 yung answer natin. So for this sample, so we have 2 because 12 is divisible by 2 and 8 is divisible by 2. So we have 12 divided 60, 2 divide, 12 divided 2 is 6. And 8 divided 2 is 4. Next we have 6 and 4. So still it is they are both divisible by 2. So 6 divided 2 is 3 and 4 divided 2 is 2. And finally they don't have any divisibility, so our answer is 1. Okay? Then we will multiply all the numbers here. So 2 times 2 is 4 times 1 is 4. That's why the GCF is 4. Okay, 7 and 20. So 7 and 20, do you think that these two numbers have the GCF? Or yeah, they have the GCF, but what is that GCF? So for 7, the factors are 1 and 7. And for 20, we have 2, 2, and 5. So just like what I've said, kung wala silang common factors, the answer will be 1. So the common prime factor, so the GCF is 1. Find the GCF of each list of numbers. So we have 6, 8, and 46. Okay, so for this portion, if I'll do the log method, it can be, but let us see the factors. For 6, we have 2, 3. For 8, we have 2 times 2 times 2. And for 46, we have 2 times 23. So therefore, their common factors are 2. So therefore, the GCF is 2. 144, 256, and 300. So we have 144 is 2 times 2 times 2 times 3 times 3. And then 256 and 300. So the common factor is 2 times 2. And that is equal to 4. Okay, so you can go back to the to this presentation if you want, if you still can understand how to get the GCF of a given two or more integers. Okay, now find the GCF of each list of terms. So this one. So what do you think is the GCF of this? Of course, we don't have we only have we have two numbers here. We have 1 and 1, 1x cubed and 1x raised to the 7th power. For this one, we have x cubed equals x times x times x. And for 7, we have x times x, and so on. So 7x. So we have the GCF of x cubed for this particular example. Okay, then 6x raised to 5 and 4x raised to 3. So we have two numbers now. And then for x raised to 5 and x cubed, obviously the smallest exponent will be our GCF. But for 6 and 4, what do you think is the GCF? So let's see. For 6 and 4, we have 6x raised to 5. Okay, there's something is wrong here. There is missing x number, no? So we are supposed to have, I think, 5x here, no? So yeah, and then we have, okay, for this one. So they have the common factors of 2 and 3x. So we have 2x cubed. So we have 2 and then 3x. That's why our answer is 2x cubed. So that's how we get the greatest common factor for an algebraic expression. Okay, another. Find the GCF of the following list of terms: a cubed, b squared, a squared, b raised to 5, and a raised to 4, b raised to 7. Okay, so this is the technique here. So what are you just going to, if the given, okay, are just letters and they have exponent, just get the smallest exponent. And for this one, we have b squared. So therefore, our GCF is a squared b squared. So that's the technique. If we have only, or if our given are just letters with their exponents. So just find the smallest exponents, and that will be our GCF. So for this one, we have AAB, 3A's and 2B's. This one, 2A's and 5B's. For here, we have 4A's and 7B's. So all of them has a common factor of 2A's and 2B's. So we have A squared, B squared. So same as what I've done. Okay, notice that the GCF of terms containing variables will use the smallest exponent found amongst the individual terms of each variable. So just like what I've said, just find out the smallest exponent if the given polynomials are just letters. But if they have numbers, or base number, or the constant number, just get the GCF as what we've done in our previous examples. So the first step in factoring a polynomial is to find the GCF of all its items. So we're done with the review. So in factoring polynomials, the GCF is the most thing that we need to consider. So then we write the polynomial as a product by factoring out the GCF from all terms. The remaining factor in each term will form a polynomial. Example, factor out the GCF in each of the following polynomials. So we have 6x cubed minus 9x squared plus 12x. Okay, so to factor out this one, of course, what is the smallest x that we have here? So obviously that's only x, right? And then 9, negative 9, and I think this is 12. So what do you think is the GCF of 6, 9, and 12? And obviously that's 3, isn't it? That all of them are divisible by 3. And that's the biggest number that I can think, aside from 6, because 6 cannot be divided by 9, although it is divisible by 12. So therefore, we have 3, okay, as our GCF. Now, we need to put an open parenthesis here. 3 divide 6. I think 6 divide 3 is 2. And then x cubed divide x. So since this is division, so we will just cancel 1 here. Because we have 1 as our exponent here. So 3 minus 1 is 2. So we have x squared. I believe you already know how to subtract, right? How to divide what they call this, monomials, right? That when you divide monomials, you just subtract the exponent. Okay, so negative 9 divided 3 is 3. And then how many x do we have? That's 2. 2 minus 1 is 1. So we still have 1x. And then plus, okay, by the way, if the exponent is 1, you don't need to put not 1. It is understood that there is one exponent here in the x, no? It cannot be 0 because if it is 0, x will become 1, okay? Plus 3 divide 12 is 4, and x divide x, since they are both have the same exponent, so the answer is 0, and x raised to 0 is equal to 1, and 1 times 4 is 4. Okay, so that's automatic. So this is our answer for this particular example in finding the GCF of this polynomial. So same thing, we just get the what they call this, the GCF of 6x cubed, I mean the factors of 6x cubed, and that is this one, and the factors negative 9 is this one, and okay, we need to add this one, and the factors of 12x is this one. So the similarities that they have is 3x, okay, and then um, we divided it to all the variables that we have here, to the three variables, okay? So this is the answer that we have here. Ito yung answer natin, no? It is the same as what I've done here, right? If I'm not mistaken, so it is the same. Okay, another. 14x cubed y plus 7x squared y and minus 7xy. So first, find the GCF of all the letters. So obviously, the smallest x is x raised to 1. And for y, we have y raised to 1. Right? And then for 14, 7, and 7, we have the GCF of 7 because all of them are divisible by 7. We can divide all of these by 7. So that's the factor. So 14 divided 7 is 2. And then we have x cubed divide x. So we have x squared. Right? And then we have y divide y, that's 0. So y raised to 0 is equal to 1. So obviously that's 1. Plus 7 divided 7 is 1. And then x cubed divide x is x. So obviously. And then y divided y is 0. Again, minus 7 divided 7 is 1. And x divided x is 0. And y divided y is raised to 0, I mean. So x, y, and xy is equal to 1. And 1 times 1 is 1. So we have 1 here. Okay. All right. So this is our final answer for this particular example. Let's see. So using this one, all right. So we will be having 7xy quantity 2x squared plus x or 1x minus 1 as our final answer for this particular example. All right. Now factor out the GCF in each of the following polynomials. So we have 6 quantity x plus 2 minus y quantity x plus 2. So first thing to do is, of course, obviously, the GCF of the two numbers are x plus 2 and x plus 2. That's the GCF. So we have, okay, so we just combine them. Then we will combine 6 and negative y. So that's 6 negative y. And the GCF is x plus 2. X plus 2, yeah. Okay? So, parang ganito lang siya. It is just the same as this. So, we have the GCF of x plus 2, right? As our, the GCF for this particular example because, we don't have any, they have the same numbers as x plus 2. And then, x plus 2 divide x plus is 1. So, we will have 6 as our, answer. Then x plus 2 divided x plus 2 is 1 times negative y is negative y. Okay? That's why our answer is like this. Okay? Next. Xy quantity y plus 1. So same thing that we've done here. So I think our, what they call this, GCF is x plus 1. Okay? Then open parenthesis, divide it, so that's 1 times xy, so we have xy as our answer because y plus 1 divide y plus 1 is equal to 1. Next, minus y plus 1 divide y plus 1 is 1, so that's 1. So that's our final answer. Let's see if we are correct. Okay, so we're done. We're correct with these examples. Remember that factoring out the GCF from the terms of the polynomial should always be the first step in factoring polynomials. This will usually be followed by additional steps in the process. Example, factors 90 plus 15y squared minus 18x minus 3 xy squared. So to factor out this one, okay, we just get the x. Okay, by the way here, since we don't have x for 90, so we will not use x, and we don't have y for 18x and 90, so we will not use the letters. We will just use the numbers. And 90, 15, 18, and 3 has a GCF of 3. Okay, that's the smallest, biggest number that we can divide for 3, 18, 15, and 90. So 3 divide 90 is 30, 3 divide 15 is 5, 3 divide 18 is 6, and 3 divide 3 is 1. And then we will just retain all the letters. That's how we do it. And now, for this one, we can, okay, so we can do this one. So we can factor out 30 as 5 times 6 plus 5 times y squared minus 6 times x minus x minus y squared. So we can factor out these two. Yeah, we can factor out these two, and we can have another answer for this, just like this one. So ilalabas lang natin si 5. So we have 6 plus y squared minus x, then 6 plus, yeah, 6. Mm-hmm. Oh, yeah. 6 plus y squared. Kasi when you multiply negative x to 6 is negative 6x. That's correct. And negative x times y squared is negative x y squared. Tama. So that will be our answer for this last example. And finally, we have 3 quantity 6 and 6 plus y squared and 5 minus x. Same thing that we've done in our previous example. So we get the 6 plus y squared as our GCF. Okay, and then matitira si 5 and negative x, and that is our answer. Alright, so that's all about for factoring polynomials. With that, thank you very much for your listening.